right, guys. So this is the beginning of Unit 2. Unit 2 is a smaller unit than our last one. We took the atomic structure content and split it up into two sections. One is the more basic atomic structure, which is this unit. And then next unit, we'll look at the more advanced, more modern atomic structure. As always, there is a vocab list on the first slide. These are things that you would want to make sure to review and look at as we go through the unit. All right, so first let's look at what atoms are. Atoms are the smallest particle of an element that retains the properties of that element. So if you had a piece of aluminum foil and you chopped it up into the smallest possible piece, it would eventually get to an aluminum atom. And atoms are electrically neutral, so they do not have a charge. To give you an idea of how small an atom is, a copper coin, so a penny, contains about 2.4 times 10 to the 22nd atoms. That is 21 zeros following that 2-4. If you lined up 100 million copper atoms side by side, that would only equal about 1 centimeter, so about the width of your pinky nail. That's how infinitely small these are. And all atoms are not the same size. The radius of an atom is anywhere between 5 times 10 to the negative 11th meters to 2 times 10 to the negative 10th meters. And you'll just kind of see in the graph below that some of the atoms are going to be larger than others. And we will talk about that in another unit. You don't have to know the exact measurement of atoms. Just know that they are extremely small. With atoms, what we're going to focus on today are looking at the subatomic particles, looking at what actually makes up an atom. So atoms are made of protons, electrons, and neutrons are the subatomic particles in an atom. You do need to be able to identify these. Right, so you do need to be able to recognize how many protons, electrons, and neutrons are in an atom, where they are, and what their charges are. So let's look at protons. Protons are the positively charged subatomic particles found inside the nucleus of an atom. The nucleus is the center of the atom. Protons do have a positive 1 charge. Sometimes you will see these abbreviated as P positive. So anytime you see that, it's just an abbreviation for protons. Looking at electrons. Electrons are a negatively charged subatomic particle. These are found in the empty space outside of the nucleus, and these have a charge of -1. So you'll see these abbreviated as a lowercase e with a negative exponent. And we'll talk about how you know how much of each is in an atom in a moment. And then neutrons. So neutrons are neutral subatomic particles. They do not have a charge. They are also found in the nucleus of an atom with our protons. You'll see neutrons abbreviated as an N with a superscript of 0. So if we're looking at an atom, you're going to have the nucleus that has the protons and neutrons, and then the electrons are going to be around the atom. All right, so let's look at how we know how many protons we have. How we know how many protons are in an atom is by its atomic number. So if you remember last unit, whenever you were looking at the parts of the periodic table, in a box on the periodic table, that number up top, say for like oxygen is 8, that top number is our atomic number. That atomic number tells you the number of protons in that element. So oxygen's number 8, so all oxygens have 8 protons. Hydrogen is number 1, so all hydrogens have 1 proton. Or something like iron is number 26, it has 26 protons. So simply looking at the periodic table, you can tell how many protons are in an atom. And atoms of different elements have a different number of protons. You're not going to have two elements that have the same atomic number. So the atomic number identifies the element. So it gives an element its identity. And since protons are positive, and we said the atoms are neutral, the positive protons have to be balanced with a negative charge in order to make the atom neutral. Therefore, in a neutral atom, the number of electrons also equals the number of protons. If you are not told that an atom has a charge, you can assume that it is neutral. All right, so what do I mean by an atom is neutral? That means that the positive and negative charges are equal to one another. So the positive and negative charges cancel out and the atom does not have a charge. So if we're looking at atomic charge, the charge of an atom is the difference between protons and electrons. So you simply subtract the two. If there's extra protons or extra electrons, then the substance will have a charge. We said in neutral atoms, protons and electrons are the same, so it has a charge of 0. In the event that we come across an atom that is not neutral, that is what we refer to as an ion, because there will be extra protons or extra electrons. We're going to look at ions later on. But another thing that we have not talked about is how you find the number of neutrons. That is going to lead us into mass number. So most of the mass of an atom is located in the nucleus. Electrons are so small that they pretty much do not have mass. Their mass is basically negligible. So all of the mass comes from the protons and neutrons. Mass number is going to give us the mass of the nucleus of that atom. So mass number is the sum of the number of protons and neutrons in the nucleus of an atom. This is going to end up being a whole number, and we'll talk about that a little bit later. But for example, helium typically has 2 protons and 2 neutrons. So if we add 2 plus 2, helium has a mass number of 4. So if you know the mass number and atomic number of an element, you can figure out how many neutrons are in that atom. So mass number is the number of protons, which is our atomic number, plus the number of neutrons. And we can always go back and forth. You may be given protons and neutrons and asked what the mass number is. You might be given the mass number and told the number of neutrons and asked which element it is based off of how many protons it has. How you're going to see atoms written. Atoms tend to be written in a couple of different forms. We typically have the isotopic symbol, which is this AZX form that you're going to see. This has the atomic number and mass number written to the left of the element symbol. And these are truly on top of one another, but it does not let me type them on top of one another. The X is the symbol of the element that is on the periodic table. Note that it is important that you capitalize letters that are capitalized and make lowercase letters appear lowercase. So make sure that you're paying attention to that. In terms of the A, that top number is our mass number. That's your protons plus neutrons. And that bottom number, the Z, is your atomic number, which gives you your number of protons. So for example, if we have an atom of gold that has a mass number of 197, you will see it written with that mass number, the 197 on top. Gold is number 79 on the periodic table. So that will be your bottom number. And gold has the symbol of AU. And notice that it has a capital letter and a lowercase letter. Another way you'll see this written is it will be the element name dash mass number. So this same isotope can also be written as gold 197. So we're going to be using both isotopic symbols. So make sure that you're able to recognize those. All right, so looking at isotopes, every atom of an element we said has the same number of protons. And if it's neutral, they have the same number of electrons. But they do not have to have the same number of neutrons, which means that we can end up with atoms of the same element that have different masses. These we refer to as isotopes. These are atoms of the same element that have different numbers of neutrons and different mass numbers. So they have the same atomic number because they have the same number of protons, but they have different mass numbers because of the different number of neutrons. For example, oxygen we said was number 8 on the periodic table. It has 8 protons, and if this oxygen happens to have 9 neutrons, that is oxygen, and 9 plus 8 is 17. So that's oxygen 17. Or we might see it written in that AZX form of 17,8,0. But we might also have a sample of oxygen that has 8 protons, and then this one only has 8 neutrons. Well, 8 plus 8 is 16. So that sample we refer to as oxygen 16, and it might be written as the 16,8,0. So you may see both ways that this is written. And we're going to do a couple practice problems in a minute from your homework, going over how you find protons, neutrons, and electrons. So I just wanted to show you what this looks like whenever we're zoomed in on the nucleus. Here it just shows you there's 3 different isotopes of hydrogen. This is in the top left corner. So there's a sample of hydrogen that has no neutrons, which would be like hydrogen with a mass number of 1. There's a sample of hydrogen that has 1 proton and 1 neutron. So that would be hydrogen 2. And then there's a sample of hydrogen with 1 proton and 2 neutrons. That would be hydrogen 3. So the protons are the same because they're all hydrogen, but those number of neutrons can change. Over on the right is one that you may be more familiar with, is carbon. So carbon most commonly has a mass number of 12. That has, here it shows the protons in red, and the neutrons are the kind of silvery color. So carbon 12 has 6 protons and 6 neutrons. But there's a sample of carbon 14, which is used in like dating fossils and stuff like that. This has the 6 protons, but it has 8 of those neutrons. So they're the same element. Notice that that bottom number, the mass numbers or atomic number is the same, but the top number, the mass numbers are different because they have a different number of neutrons. I do want to switch over to your homework. I'm pulling it up digitally, but you guys will have it on paper. Excuse me. Whoops. There we go. Sorry about that. So this is your part 1 homework that you're going to be going through. You're going to turn this in on paper, but I just have a digital copy. So a lot of this is just kind of going through the notes. I will tell you right now, skip number 4. that is going to go with tomorrow's notes. But here you're just kind of finding what word would fit there. It's like for number 2, the number of protons in one atom of an element determines the atom's identity. So we said that each atom has a certain number of protons, and the number of electrons determines the charge of the element. Because remember, charge was the protons minus electrons. So you're kind of thinking of what would go in those blanks. And some of them have multiple options of what would go in there. This first page, it just takes you through some of the same things we did. So like give the symbol and number of protons in one atom of lithium, if you find down the periodic table, is number 3. So it has 3 protons and its symbol is capital L lowercase I. And that's what you're doing for these. I do want to look at the next page. This is what I want to do part of together. So the table like this kind of helps clue you into some of the other questions going through the same process. And we're going to fill in probably the first 2 rows of this together. So this has you looking at the periodic table and trying to fill in all the rest of the table. I will tell you one of the questions we talked about mass numbers or whole numbers. If you notice on the periodic table, the masses or the number on the bottom of each box, a lot of them are not whole numbers. So in the event that you are not given the mass, you need to take the mass of the periodic table and round it up to the nearest whole number. So let's fill in the first row together. All it tells us is that this element has the symbol of Na. If you scroll through to find Na on your periodic table, Na is sodium. Which is number 11, which is our atomic number. So remember, atomic number is Z. And it tells us that sodium has a mass of 22.99. Well, a mass number needs to be a whole number. So 22.99 is going to round up to 23, just whatever the nearest whole number is. For number of protons, remember, number of protons were equal to the atomic number, which is Z. So atomic number was 11. So we have 11 protons. These are atoms. So remember, they're neutral. So it also has 11 electrons. Oops, excuse me, that was a little messy. And for neutrons, remember we said mass number is protons plus neutrons. So it tells us our mass number is 23. So if we do 23 minus protons, which is 11, we get the number of neutrons. So 23 minus 11 means that we have 12 neutrons. The isotopic symbol is that AZX form. So our A here, our mass number was 23. Our Z, our atomic number was 11, and our symbol is Na. So that's what you're doing to fill in each one of those spots. Let's do the next line together just for good measure. So the next line, it tells us that our Z, our atomic number, is 17. If you look for number 17 on the periodic table, that is chlorine. Chlorine has the symbol of Cl, which is number 17 on the periodic table. And chlorine has a mass of 35.45. So that would round down to 35 is the nearest whole number. So number of protons was equal to the atomic number, which was 17. That's the same as the number of electrons, which were already given to us. For the number of neutrons, we have to do the mass number, which was 35, minus the atomic number, which was 17, which leaves us 18 neutrons. And our isotopic symbol, that AZX form, is 35, 17 Cl. So you guys are going to be able to do that part 1 of the homework through this table, but you cannot go past this table for today. Hopefully that helps get you started, and I will see you guys tomorrow.